video, we're going to look at the enVison's Algebra 2 math book. We're looking at exponentials, and we're going to look at the transformation of exponentials and the format that the transformation has to follow. So I'm looking at topic 6-1, example 2, graph transformations of exponential functions. So let's talk about what the transformation pieces are. So just like in radicals, we have certain parts of our functions and we have other parts that don't get transformed, that get simplified and then become vertical. So in our case, everything's going to become a vertical. So we're going to have a vertical stretch or compression, or we're going to have a vertical shift. And these are the two categories that all our transformations can fall into via simplification of our expressions. So the pieces that we have here are f of x equals abx, we saw this in the last example, plus k. All right, A is going to be my vertical stretch. Or compression. And remember, the stretch is A greater than 1. The compression is A less than 1, greater than 0. All right, K is a vertical transformation up or down. Transformation, or translation, let's go with translation during. Up or down. And then if you have a negative for your A, so if you have a negative A, then you're looking at a mirror across the x axis. All right. So I'll give you a second, or you can pause the video to write this down, and we're going to jump into an example. We're going to look at f of x is equal to negative 3 to the power of x. All right, my A in this case is negative 1. Since we have this negative here, we're going to look at that mirroring across the x-axis. All right, so I'm going to first start with my parent function. I'm going to start with 3x. Trying to get that at an angle of 0. If you look at the bottom of the screen, it actually says it. All right. My sound effects, they're fantastic. I always have such fantastic sound effects. I should actually, back when I was a child, this is going to date me. I mean, I'm already dating myself most of the time when I say I lived with the dinosaurs. But we used to have Police Academy. There used to be a guy who made sounds with his voice. I used to think that was the coolest thing. All right, so I know from this, long story short, let's get back into the math, that I'm going to cross that 1. All right, when I'm looking at 3 to the power of 1, that's going to be 3. 3 to the power of 2 is going to be 9, and so on and so forth. When I'm looking at 3 to the power of 1/2, that's basically the square root of 3. I don't know, some decimal here. So 3 to the power of negative 1, 3 to the power of negative 1 would be 1/3. 3 to the power of negative 2 would be 1/9. Again, you're taking the reciprocal when you have a negative power. 3 to the power of negative 3 is like negative 127, something down here. We get closer and closer to 0. We do try to cross that 1 and we grow up like that. All right, not the best graph. You guys have seen my graphs. You know what to expect. But now we're going to take each one of these values and we're going to multiply each one of these by negative 1. So this value of negative 127, or positive 127, now becomes negative 127. This one of 1/9 becomes negative 1/9. this one of 1/3 now becomes negative 1/3. 1 times negative 1 is negative 1. 3 times negative 1 is going to be negative 3. And this would be negative 9. Negative 3, negative 9. Just because this is not actually drawn to scale. And we get this mirroring across the x-axis. The asymptote of this function actually does not change. It's approaching, it's getting closer and closer to the x-axis on the left-hand side. The end behavior on the left gets closer and closer. The right one goes to negative infinity. So we're seeing the end behaviors kind of flip for the right end behavior, but we don't see much more. So this is a mirroring across the x-axis. This is a transformation of my function, and we will look at another example. So the next example I'm going to look at is f of x is equal to 3 to the power of x minus 4. All right, right away I can see that this is a translation down from my 3x. So I'm going to get back to my, that's pretty cool, back to my graph here. My nicely drawn lines. I wish I could just have 2 of these already set up. I'm sure there's a way for me to do it on this software. Okay, so my parent function went through 1 here. At 1 we were at 3. At 2 we were at 9. Let's see if I can hit that. Let's see if I can get there. And there. Again, not drawn to scale. Since this is basically a hand sketch. Alright, so now we're going to go down 4. So I'm going to take each of my outputs. This 1, I'm going to go down 4. 1, 2, 3, 4. This 3, I'm going to go down 4 to negative 1. This 9, I'm going to go down 4 to, I don't know, 5. Again, not drawn down to scale. That's the same for each one of these points here. So we're looking at something like this. Now here we have a change. We have a change in our asymptote. So we are no longer approaching 0 in this case. We are going to be approaching k. So my horizontal asymptote for my transform function is y equals negative 4. My end behavior, so this means that my range changes. Y is greater than negative 4. And my end behaviors, as h approaches negative infinity, y approaches negative 4. X approaches infinity. This still is the same. Y approaches infinity. All right. So that 4 has an impact on my domain. It has an impact on my range. And it also has an impact on my asymptote. So now when we start looking at this, we can now redefine what my transformed function is going to look like. So if I have a b to the x plus k, you can start seeing how these two change your domain, change your range, and change your horizontal asymptote. Now going along with this, one more thing to note, because they did not have it as an example, but they do have it as a try it, is if you have something like 5x plus 3 as your function. Again, we have the pieces a and k, but we don't have this piece. What we can do is we can start looking at those exponential properties. So we talked about if you have a base b and you have it to the power of x times b to the power of y, you can simplify these to be x plus y, which means you could also expand this into bx by. Alright, so looking at this, we have 5x times 5 cubed. And 5 cubed, I believe, 5 cubed would be, I think, 125 times 5x to the power of x. So now we have it in this format. We have it in the ABX format. All right, also, if you have something, because they do this in the triads, 5 to the negative x, we take the reciprocal. So if you have 5 to the, or b to the negative x, that's the same as saying 1 over b to the x. So I can actually say that this is 1/5 x. And now we have an exponential function again, and this one will go downwards. Well, this one will go upwards with a stretch of 125. Alright, so there we go. If you guys have any questions, please feel free to contact me, and I will catch you in the next video.